Hey, what's up? This is Mark at Alchemist.camp, where we learn Elixir and Phoenix by building things. Today we're going to build Pagination into an existing Phoenix app without using any dependencies whatsoever. And that's for two reasons. One, it's pretty easy to do, so there's no real need to pull in an external library. And two is it's easier to keep control of all of your code if it's in your app as opposed to in some dependency, because you're probably not going to dig into your dependencies and make adjustments even if you want to. So it it's kind of a trade-off, and I think with a huge thing like Phoenix, it's totally worth it to pull it in, especially since very little cost to performance. But with just one little thing like pagination, we might as well just do our own and then be able to control it completely. So let's have a look at the project. This is called StatWatch, and for those of you that have been following Alchemist Camp for a while, you'll know that StatWatch is a free app that just lets people input their site, their Twitter, and their YouTube channel, and it will log stats every day on how many subscribers, videos, and views they have on YouTube, how many Twitter followers they have, and the Alexa rank, which is basically a popularity ranking for the site. So you can see Alchemist Camp itself is about the 2 millionth most popular website in the world. The parts of StatWatch that we're going to paginate are actually just going to be related to the profiles, because as you can see, the profile pages just keep logging entries, and if you've had one up for a while, it ends up being a lot, and it would make sense to paginate this instead of just adding more and more and more lines to the same view. In an ideal setup, we would have a certain number of entries shown on each page. We'd have links to go to the next page, previous page, and those pages could also be accessed just by using a query string parameter like page equals 4, and then we would just load the fourth page of stats instead of every single one like we have now. But of course we want our pagination set up to be flexible enough so that we could apply it to other kinds of pages later. So we'll have one module that works with Ecto queries, and it will take a query for something like profiles, users, blog posts, whatever. It'll take that query and then it will spit out the appropriate rows from the database based on the page and how many entries per page were specified. And it will also include some metadata, like whether if there is a set of queries afterwards, like is there another page or not, and is there a previous page or not, and what page are we on, and how many entries are there total. So that'll be one piece, and then we'll need a view helper so that it's easy to use this inside of our templates. And ideally, the view helper would have something to show how many entries there are. Maybe something will say like displaying page 2 of 10, or displaying entries 20 to 30 of 103. And then we'll have another helper for our templates that generates the previous and the next links. And that's pretty much all we'll need. Of course, we'll have to make some very minor changes in our controller and in our context. With that preamble out of the way, let's get started. So we have our StatWatch project here. We have StatWatch and StatWatch Web. In StatWatch, we have our core context, and core has profiles and stats, and every profile has many stats, as we just saw. We'll make a file at the root level of the StatWatch directory right here, and we'll just call it statwatch.pagination, or we'll call the file name pagination.ex, and the module will be statwatch.pagination. We'll need to get Ecto, or ecto.query, and let's get rid of the terminal and bump up the font size a little bit. And we'll also alias our repo. Our first function will be called query, and it's going to take an Ecto query as its first argument, and it'll take a page number, and it will also take a per page, and that's going to be an argument like so. And since that page number in some cases at least, as I just showed in the browser, might come out of the query string in the URL. That would be a string, and we want to make sure that we handle that. That's always converted to an integer. So we'll make one form of our function is going to have a when clause, a guard clause here, when it's binary, which means a string. Then we'll convert the page to an integer. So we'll pass every argument along the way it was, except for page, which is going to use string.toInteger to convert the page, which was a binary, aka a string, into an integer. And per page also goes just as it was. Okay, and then we'll make the normal version of the function. So it's going to take the same arguments, query, page, per page, per page, and there is no when clause. And in the main part, we'll start with our query, and great thing about Ecto queries, what makes this whole episode possible, is we can actually just keep building onto the query. We've got some query. The query may have just been something like profile where user ID equals some ID, order by name descending. And we can pass that query, whatever it was, into a pipeline and add some more parameters to it. That's what we're going to do. We'll start by setting a limit, and that limit should be whatever the value of our per page is, except that we actually want to set it to one more than that, so that, say we request 6 results, if it were 5 results per page, if we get 5 or less, then we know that that's the last page. But if we get 6, even though we don't want to display that 6th one, we know it's not the last page. So we'll throw in a +1 here, and then an offset, which says where we start getting queries, and the offset is going to be the per page value times the number of pages minus 1. So if it's 10 entries per page and we're on page 1, that's going to be 10 times 1 minus 1, which is 10 times 0, or 0, because we start from 0 on the first page. If I have too many, I do have too many. No, actually we do want 3. Then finally we'll call repo.all to just get whichever results have been selected by our query. And we could just display those results in a page as they are, just like we would with any listing. But as I said before, it's better if we have a little bit of metadata so that we can display previous and next links and handle that logic. So we'll make another function called page, and page is going to take very similar arguments. In fact, it's going to be identical arguments, so I'll just do this the lazy way. And instead of being called query, it's going to be called page. So that's our guard, and then the real function is going to take those same arguments. I'm once again going to be lazy here. And in that function, we'll start with the results that we got from the query function. So we'll call query and save the results in a variable called results. Query is going to take the query, the page, and per page. Next thing we'll do is set a boolean for whether or not there is a next page. We'll call it hasNext, and it's going to equal whether or not the length of the results, in other words, the number of results returned, is greater than the per page value. And remember up here, we set the limit of the query of per page +1. So we tried to get one more result than asked for. If that succeeded, that means there's a next page. If it didn't, then there isn't another page. Then has previous is even simpler. As previous is just going to equal whether or not the current page number is greater than 1. Or on the first page, there are no previous pages. Otherwise, there are. Then most pagination systems will say the total number of results. So we've got to get that. We'll call it count. Count is going to be repo.1 from t in subquery. So we want to do this in an inexpensive way. So we'll use this query and we'll just select count. And Postgres or whatever database we use will know what to do with that and get us the count of the total number of results very cheaply without getting the other information about those results. Then finally, we've got to return a blob to our users. Scroll down a bit here. So it's going to be an object, and we'll just return all of this information we have about the results, as well as the results themselves. Has next is going to be has next. Then has previous is going to be has previous. We need to get the previous page, like the number of the previous page, and that's going to be previous page is page -1. We want to get the current page. We'll just call that page. Then we want the next page, which is going to be page +1. And the way I'm doing it, even if there is no previous page or no next page, these will exist. So anytime we're doing a check to see if there is one or not, we've got to use these booleans has next and has previous. And the first entry in our set of results is going to be page -1 times per page +1. So for example, if we're on page 3 and it's 10 results per page, that would be 2 times 10, so that would be 21. So third page would be entries 21 through 30. When I get the last entry, it's a little bit more complicated. Usually it's going to just be page times per page, but on the very last page there might not be that many entries, so we will use enum.min to get the smaller of page times per page and count. Then we need the count. Then we'll also give the user the list of results. We'll just call that list. And remember, we tried to get one more result than we actually want to give the user, so we'll use enum.slice in order to get rid of that one. So results from the 0th one to the number per page. And that should be enough information for the view to know what to do with all this stuff. And let's open up the terminal and have a look at it now. I've got it running on development, and it's not exactly the same information, but there are a bunch of profiles. So let me alias statwatch.core.list profiles. So you can see I've put in several profiles, and there are 6 of them. Now, what happens if we use this new query here? I guess I'll have to alias profile as well. So alias core.profile import ecto.query. If we were to say profile where user ID is equal to 1 repo.all, I named it a little oddly. It was statwatch.profile, so alias statwatch.profile. Try that again. Okay, so that worked. And instead of getting all 6 of these, let's try using that helper that we just made. So this is our query without the repo.all. Statwatch.pagination page, and pass it our query, and then a page number. We'll say page 1, and then per page 3. Might have to recompile here. Cannot use per page -1 outside of match clauses. That's in line 12. That actually looks fine. is in a match clause. Except that I misspelled offset. Okay, offset. Recompile that. Now everything's okay. All right, so go back and try this again. Statwatch.pagination.page query, and the query is the one that I just saved above. Profile where user ID is 1, and we're just going to get 3 per page. Look at the first page of it. And here we go. So we have a count. The first element is number 1, the last one's number 3. There is a next page, and we have a list of results here, and then next page value, and let's try getting the second page of that. Now you can see we only have 2 results, and there is no next page, but there is previous page. Now that that's working, let's use that in our core context. So as you can see, we've got a couple of profile functions. One gets every single profile, and by profile I mean the Twitter / YouTube / site profiles that we were looking at, and the other will just get all the profiles created by one user. So let's add a couple. Let's add one that will get profiles, that'll get all the profiles but paged. Then we'll add one that will get all the profiles for a user and be paged. So we'll start with the simplest one, which is list profiles of all of them. We'll have it take an atom paged, just to make it very clear we're not getting a user, we're getting a page of results, and page number and per page. We're going to make both of those optional in a second. And this is pretty straightforward, so it'll just be the profile, and we're going to order them by the name of the profile. So order by descending name, and then instead of calling repo.all, we'll just use pagination.page and pass along the page number per page as so. I guess we'd probably better include that module so that we can just call pagination like that. Pagination. Let's check it out in the terminal. So core.list profiles has to be capital. That gets them all, and then if we pass it the atom paged, page 1 and 3 per page, looks good. Let's declare some defaults for this function. So it'll still be called def list profiles, but there's no do at the end, and we'll just put defaults for the arguments where there are. So the first argument, there is no default. Second argument of page will default to 1, and per page will default to 5. This won't quite work though, because if we use default values for both page and per page, just get one argument, well, this will match anything with one argument. So we have to make sure that it's actually a user. So we'll pattern match on line 17 so that list profiles will only run when there's a user, and we'll have to have users aliased. And let's try core.list profiles. That's all of them. Now let's try paged. We'll just use the defaults. And it looks like we got 5 results as expected. Finally, we're going to have a version more like what we have on line 17 here. And just to make this clearer, let's put this into a pipeline syntax. So profile where user ID is user.id repo.all. Okay, so that's no change to list profiles. It's still doing the same thing it did, but we can just copy the same kind of pattern down here, and instead of just matching user, we're also going to get number of pages, and we're going to get per page. Let me save once just to get rid of all that white space. accidentally added in there. Okay. And profile, where the user ID is the ID of the user it matched. Then instead of this repo.all, pagination.page of page per page, and that should do it. I guess let's also order this the same way as the others for consistency. So in order of the name. Start by getting a user. So our user is statwatch.accounts.get user number 1. Okay, that one is me. And core.list profiles for user, and we'll get it paginated and just get page 1. We got results 1 to 5, and there are only 5 that belong to user number 1. So let's add a per page of 2. And there we go. Let's have a look in the browser now, in one running locally. So here are all the profiles. So we'll change this page to use the new functions we just made. So first we need to go to the profile controller, and we're going to use these parameters to get the page out. So page is params of page, if there were any. Otherwise, it's going to be 1. Now our profiles, instead of just core.list profiles, will be core list profiles page, and then whatever page we've got. This is not quite the same shape as we had before. If we go back to this pagination helper, you can see this list is analogous to what we used to be getting. So inside the index page, we'll have to make a change. Our index is going to show profiles.list. We have a current page. We're going to need that same logic. So I'll go up here and grab that, and list profiles user page. And we're not going to pass in the per page. We'll just keep that with the default. With that, should be updated. So now we can see 1, 2, 3, 4, 5 instead of 6, which we used to have. And let's try going to page 2. Excellent. And next is our show page. The show page is going to be a little more complicated because these are actually not in the same model. These are all stats. These stats are preloaded into a profile for the show page. And what we want is a profile loaded up with a selection of these stats with pagination information. There's a bit more complexity in that, so we're going to make a helper in our context at the bottom and call it page of stats. Page of stats is going to take a profile, and it will take a page, and it will take per page. It's going to be almost the exact same thing we did for the listing of the profiles. So we'll build out query stat order by. This one is going to be ordered by time, because that's kind of the whole idea of this, is we can see stats of our projects over time. So inserted at, and where profile ID, actually, you know what, we're going to make this function take profile ID instead of profile, where the profile ID is whatever profile ID got matched out of the top, profile ID. And then instead of repo.all, we call pagination.page, page, and per page. And that's really about it. We're going to make another function head though. So page of stats could take a profile struct, get a schema that's already been pulled out of the database, and it will pass that in as a profile ID. So we're just going to use short variable names here, make it a one-liner. So given some profile, we're just going to call page of stats with that profile.id, and I'm not going to change any of the other arguments at all. And we'll also make some defaults, so page of stats, whatever kind of profile we got, and the page is going to default to page 1, and per page is going to default to page or 5 per page. And now we can use this helper so that when we get one profile, we can make a paginated version of it, that instead of getting all of the stats in that order, we just get the ones for the page requested. So we'll say get profile by name, and now instead of just taking a name, we'll also take a page and a per page, which will default to 5, and we'll need the profile first before we can use our helper. So profile is repo.getBy profile and the name that was passed in. They'll get us the profile, and we'll preload the user. Our stats will be page of stats with that profile.id, and the page and the per page. Then what we want to return is the profile with the stats embedded in it. So do map.put profile, and we could just put it under stats, but I think it's better to put it under paginated stats, just in case there are different parts of the application that paginate things or don't paginate them. We don't want to have any confusion. So stats will be preloaded if we do it here. In this case, stats are not preloaded, but we've just loaded a small paginated subset of them. Paginated stats and stats. So that will put these stats into the profile object or profile schema. And we should be good to go. Let me recompile here. Core.get profile by name. Alchemist. That would get all of the stats, but we just want one page, so page 1, and stats are not loaded, but we have some paginated stats. Then inside of there we have a list. Let's use that in our controller just like we did for the index pages. As above, we get the params, and then page is going to be equal params page, if there are any. If not, we'll just set it to page 1. Get profile by name, name, page, whatever page we got. Show the profile, and we'll have to go to that show page as well. Profile show. We'll get all the stats from profile.stats, profile.paginated stats. .list. We use profile.stats anywhere else? We did not. And now we're just showing 5. Got the second page, the third page. All right, so that sets up the back end or the API part of doing pagination, both in a really simple case where we're just doing a listing, and in a more complicated case of getting a paginated subset of one schema and embedding it in another. Next time we'll cover making a view helper so that with a single snippet in any of your templates you can get next and previous buttons showing up where there are next or previous results, and then another snippet for showing which results are being listed, like say listing results 21 to 30 or something like that. Till then, code on.